This video is going to have a look at the 4 gas tests that come up at GCSE, and those 4 gas tests are for hydrogen, carbon dioxide, chlorine and oxygen. And what's really important to remember here is if you get asked to identify a gas or how you would do that, it's always worth 2 marks. And the first mark is always for describing the test. The second mark is for doing the positive result. You cannot get the mark for just writing the positive result. However, you must have the first part correct. To give you an example, hydrogen, and we'll look at this in more detail, uses something called a squeaky pop test. If you just said squeaky pop, you won't get the mark. It is the second mark, but you can't get it because you can make a squeaky pop in lots of ways. You need to say how you're showing that squeaky pop has come from hydrogen. And there are 2 reactions that are probably the most common ones that link onto these questions on gas tests. So the first one is an acid, let's say hydrochloric acid, plus a metal, let's say potassium, is going to give me potassium chloride plus hydrogen. Quite a nasty reaction there. Now, if we balance that out, that would be a 2, 2, 2. But you would be testing for this gas here, for hydrogen. The way you do that is a squeaky pop test. So you collect the gas, put a lit splint into that gas, and if you hear a squeaky pop, you've got hydrogen. The other quite common one is this one, which is a metal carbonate. So if we take, let's say, hydrochloric acid and react it with, I don't know, sodium carbonate, Na2CO3, what I will get is my salt, so sodium chloride, in this case NaCl, plus water and also carbon dioxide. Now, balancing that, because we should balance it, that would be a 2 in front of that. That should be a 2 in front of that. And I think that balances it out completely. What we'd be testing for is this, the carbon dioxide over here. And the carbon dioxide is a test where you turn lime water cloudy. So how do we collect the gas? Now, this doesn't really work for the carbon dioxide. That's a slightly different method. However, most of the gas collection you would use this apparatus, and you do get asked to draw, label, describe and explain how this apparatus works. So I tend to prefer to use a boiling tube here. It doesn't stand up on a desk quite as well, but it does have a smaller volume, sort of like this residual gas here. So you collect the gas earlier on. Now, what's important here is that you have got a bung on. Quite a lot of the time people forget to do that. And if you don't put the bung in the diagram, the gas will just escape out of the sides here. So it's really important that this is sealed. And that means the gas is forced to go up the delivery tube, down here, and then into the boiling tube. The other really important points is that the delivery tube is underneath the water and directly underneath the boiling tube that's collecting the gas, or the test tube. The test tube is submerged below the water. Now, the test tube would be filled with water, turned upside down, and then the bubbles go up. That displaces the water back into the trough, and you would then put your finger over, or you would put a bung on the end here, turn it upside down, then you can test for the gas. Something to bear in mind when you do this, you need to wait a couple of minutes before you start collecting the gas. The reason being that the first bit of gas that is that leaves the conical flask is going to just be air. So you need to wait a little bit to sort of purge the air from this area before you start collecting the gas. So the 4 tests you need to know. And this is how it comes up in an exam. If you are asked to test for hydrogen, you get a lit splint and you get a squeaky pop. If with carbon dioxide, instead of collecting the gas like you would here, you would bubble the delivery tube straight through lime water. And you can see a delivery tube here. Those bubbles then turn the lime water cloudy, and that's a positive test. Oxygen, you light a splint, you blow it out. If it relights, then it's oxygen that's present. And chlorine, now litmus paper is an indicator. It goes blue in alkali and red in acid. If I take damp blue litmus paper, what will happen is the chlorine will dissolve in the water that makes it damp. That will turn into hydrochloric acid, which makes it go red because it's now acidic. And then because chlorine is also a bleach, it will then go white. So it turns damp blue litmus paper red and then white.